this video I'm going to do an introduction to the vision control. I'm going to go through the basics so you can kind of understand how the system works. We'll go through a small program. I'll show you around the screens and have you get to know the new vision control. One big point on this vision control compared to the older ones is this is 100% touch screen. Everything is done by touch. If you need to enter values, numeric values, it'll be through this little touch keypad. Okay. So keypad's not necessary. You could plug one in if you wanted to work in conjunction with the touchscreen, but the touchscreen alone is more than suffice. Okay, I'm going to give you a little. I'm going to give you a tour around the screen, this home screen initially, to explain some of these things. Up over here on top, we got our start/stop button for our programs, a reset button for the programs, or for a program, or for machine alarms and so on. Over here is where we can turn on the hydraulics, servo, and clamping. Over here we have 4 tabs. This is to indicate my home tab, which we see here. We use this for jogging, the RAM, the back gauge, and so on. And then we have our 3 methods of programming. We have our profile mode, which you're drawing a profile, and these 2 here based on a table, and you enter your values to program your part. You can see up here, these are these little guys here, and these, if you touch on those, you'll get your jog buttons here, so you can move the axis up and down. We can indicate a tonnage when we're going to move it. Here, once you highlight one of these, you can just go forwards this way or backwards to move the axis in whichever direction you choose. Same thing goes into here. If we unselect those and we select, say, this X1, now if I have that selected, you'll be jogging just that axis, and it'll indicate with an arrow on the axis that is moving. Okay, and you could do the others as well. And I could also select multiples together and move them together. Okay, that's just for basic jogging. It's not something you do a lot on these machines. And up here, basically, where you see this little program, it'll say your program name and some specifics about that program. But if I hit program here, I will get my little menu for doing a new program, opening a program, importing, and so on, exporting a program, reporting an issue, WebEx button here to connect to the factory, and importing a machine if you're using their 3D offline. Also, I want to show you here real quick. We can navigate through our Windows system. This is based on Windows 7, so we can see all our drives in place. We can go to a folder, see where the programs are at, and so on. So it's standard Windows interface here, or navigation, and we can delete files and rename files on the same view. And you can see here we have shortcuts for moving up a folder, going to the main window, home screen, and adding a folder. So real simple, real straightforward, all touch based. Okay. Okay, in this video I'm going to show you how to do a profile program. And when you start a new program, first thing it'll ask you is what material you're going to bend. Next thing we need to enter is our material thickness. So we're going to say 045 for 18 gauge. And then on this next step, I want to indicate the width of the bend. Let me just say 4 inches. And then we're going to go into the point where we tell it what our profile is going to be. So when we're doing this, just tap on the screen where you want to create your shape. So I'm going to tap. Okay, create my shape. Don't worry about scale or dimensions at this point. Just make the shape that looks correct. Okay, on the next step, we're going to go up here and hit dimension, and we're going to give these numbers. We're going to enter what dimensions we want to have. So I'm going to enter 2 inches on that one, 4 inches on this one. You can see I'm making big changes. It just fixes it and fits the screen again. We're going to make this 1.5. This is 2, and that last one's 1. Okay, now it wants to know the angles for these corners, so that first one, 90, is okay. This is going to be a 135. This one's also going to be a 135. And the last one's a 90. So we're all set. I'm going to hit OK. We're done dimensioning. You can see our basic shape and it's dimensioned. Let me point something out real quick. When I highlight a segment, you have this little box over here that shows me how I'm dimensioning. This is the better example. Now when I have that line, it's going to be 4 inches, and over here it's going to say out and out. So I can dictate whether this measurement is going to be an outside to an outside. I can also change it inside to outside, tangent to outside, and this changes accordingly as well. Okay. Obviously the most common one is going to be outside to outside, but you have that choice. And also you can create a dimension based on a horizontal and vertical dimension, or an angle and a length. Okay, so we have a lot of options there for dimensioning. Very handy. Okay, so next thing I want to show you is when we created this profile, you'll see over here it calculated a bend deduction, or not a bend deduction, a flat. Calculated a flat for us based on this V opening, V width here, 236. I prefer a bigger one. I use a 039 or a 394 myself. So I'm going to select that, and you'll see it updated my flat here for me. Okay. This also helps select the tool. So when it looks for a tool, it's going to look for that V die width. Here's a scenario. Happens often. This one is telling me my flat, my shear length is going to be 10.269. It calculates that with the bend deductions from the tables, from the bend tables in here. And then, but a lot of times we get, maybe in a job shop case, a customer will bring in a piece of material that's already been sheared and he wants this profile. They make some assumptions and they maybe give you a flat that's not correct. So if you have that situation, you'll type in over here what your actual flat is. So it wants 10.269, but let's say it's really 10.25. Not a big difference, but enough to be a pain. So now it knows the flat. So in my next step over here where I hit adjust, it's going to take that difference between the flats and take that error, and it distributes it throughout the part. Okay, that's handy, that's fine, but maybe you have some dimensions that are critical. For instance, maybe the height of this or the height of this, or maybe this angle. So you'll see these little locks symbols here. So whichever ones you want to be locked and not be altered, you highlight them. So let's say I want that one locked, and you'll see it transferred that error to these and left these alone. Okay, so that's going to have an influence on our sequence, okay, and how it's going to gauge. So this makes life real easy when you get that situation where you don't have matching blanks. Okay, so real simple. So move on to the next step. We're going to do a sequence. Okay, you'll see here a blank view of our press brake, no tools in place. So what I'm going to do is hit this play button. And what it's going to do is come up with a sequence, okay, and it'll also show me my tools and my part, and I can actually tap on the screen here and go through the bend, okay, go through each step. Oops, what I did there accidentally was open the tool that's selected, and you'll see it's at 394 and OZU 810. I could change it if I want to. Okay, so you can see how I can simulate the step. It'll show the back gauge. Same thing with my upper tool. I can select a different style tool if I choose. Okay. Also, you saw that we did a auto sequence, but maybe you don't want an auto sequence. Maybe you want to do it yourself. Well, if I want to do a manual sequence, all I do is pick the bends manually by hand. Okay. Very different sequence here, but it works as well. Okay, so if that's your preference, you can do that. Now, if you do a sequence and there's going to be a problem in it, it's going to have a collision, it's going to start flashing on that sequence where where there's going to be an issue, and you'll probably see the collision on the graphic screen. So you can do manual, or you can do an auto sequence. Okay, at this point, the part has been done. It's programming. I can go to the simulate button, and I can basically do the same thing we saw on the other screen. Okay, and so this part's programmed. You can hit OK, and you can actually hit the start button and start running this part. Okay. Okay, so we just finished the profile program. We're going to go to the next step. I'm going to show you Flange. This is something unique to this machine. What it actually did with my profile program, I created a flange program here. This is exactly the same program we saw previously on profile, but in a flange mode. Okay, so this system allows me to start by programming with profile, and then I can just do all my other editing and tweaking in this flange mode. You'll see several tabs up here. The part lot's the same as before, like you saw earlier. This tools will show me the tools and their position. If you're going to be doing stage bending or multiples, you will have more here, and it'll indicate where they are on the press brake. This will also help dictate where the Z1 and Z2 fingers position to. Next tab here, bend. These are my actual bends. You'll see I got 4 bends. Over here, the critical one is going to be angled. You can see they're all 90 degrees. They get that little blue triangle in the corner there, those indicating that we're automatically calculated. Okay. Here's some flange lengths for my different bends. It shows the bend width, okay, and it shows my bend deduction it's using. It's pulling that from its tables. Over here I have flange comp and angle compensation, or correction, shall I say. And you use that after you start bending the part. You do an initial bend, you measure it. If the angle's slightly wrong, you come in here and type in the angle that you need to correct. You type in what you measure, put it into there, and it'll correct my program. Same thing with my flange. If I flange a little long or short, type in what you measure here, and it'll correct the flange. Over here, this is just telling us where we're positioning the finger to, tool sets in case you have more than one, and the tools that you're using in the bend. I can change these here if I like, as well. I can also edit any of these features. Okay. Next tab we have is a back gauge. It's got all the back gauge information. X1 position. Okay, that's our flange again. X retract. Now the system knew it needed to retract, and you can see it put those in there automatically. I didn't have to. Corner gauging. If you've got a 3D back gauge, you can indicate if you're going to be doing some side gauging or something. That's what that's for. And this rest 1 and this rest X1, X2, that's essentially telling it on the several steps of our finger whether we're doing it on the face, on the first ledge, or the second ledge, and we would select that here. Okay. Origin here, this we hardly ever touch, but it's always on the machine left. You can change it if you like. Z1, that's going to be for the finger positioning. And it tells it where it's at. We have a scale on the rams. It'll start from 0 up to the width of the machine, whatever it may be. This one's a 12-footer, 144 inches. And you can, this will select it for you. And if you look, see here at Z2, I can position this. I can enter in a different value for my Z2 if I like. We're going to tell it 75 inches. We're going to keep the fingers real close together. If I wanted to change these, I could just punch it in and type in a new value. Also, I have my R axis, the height of the finger. Okay, it's being programmed. You'll see slightly different heights because it's moving the gauge up or down, so it's actually gauging on the most optimal point of your part. Okay, so the next step is my RAM tab. This is like our bend tab, but it's showing absolute numerical positions for the RAM. It shows my Y top, so that's the distance that the RAM comes up after the bend. My Y slow, that's the position when the RAM is coming down where it switches from high speed to bend speed. Okay, over here will be pinch point. Well, actually, here's pinch point, Y1. Y2's got a different pinch point. Since this is a Y1, Y2 machine, if it says equals, it means they're both identical. Okay, Y bottom is the depth that it's going to go to achieve the angle that's being programmed. Again, you can have a Y2, Y bottom. In case you wanted to have a tilt into the RAM. Here's a bottom correction. So if I were to put in a angle correction on the previous bend tab, the correction will show here, okay, in thousandths of an inch. And if you want to have a return delay, you can indicate it there. Crowning would be added here. It's usually entered automatically if it's a CNC control. And then there's the bend speed, Y speed right there, 100%. You can slow it down if you like. Actually, it's going to be bend speed. The tonnage for that bend. And then this last one here is actually showing us how much penetration is needed per degree of bend. So in the case here, it says 4/10 for 1 degree of bending on this type of material. The other thing we have is these options where I can turn on slow return, double stop at slow point, double stop at pinch point. If I have dual pedals, I'll indicate which pedals I use for which step if I wanted to. Safe R or safe Z, that pulls the fingers back before it ever moves those positions on the R. And then this is when the back gauge moves to the next step. When it returns back to the top, there's quite a few. At the pinch point at the bottom, so you can really customize how your machine reacts when you're programming it. And this is for certain laser guarding systems. You can program this if it's box mode per step. Okay, very handy page. And then we also have the ability to do some bump bending, where you can indicate the radius, how many bumps you want to do it in, and it'll calculate everything for you. Okay, so that's our flange mode. And the next mode that we have here is position mode. This is almost all identical. You'll notice a few less tabs. This mode is purely positional values. There's no intelligence in this view. A lot of the older shops program in this method, where you just indicate where the Y has to come down to achieve an angle. That's all it is. And so we have the same thing for back gauge. This is just actual positions for the back gauge. The RAM, actual positions for the RAM. Okay, and you got the same options, the same bumps. But as you noticed, I made the one profile program and I have values in all three of these. That's the nice thing, is I can alter a program after I create it in a profile mode. I can alter it in these various methods that suits me best. And so that gives you a lot of flexibilities. The older machines never let you do that. You picked one mode and that was the only mode you got. So you kind of get an idea of what it's like to program. Keep it very simple, not complex at all, and easy to use and quick to learn.